Good morning. I'm super excited to be hosting this panel and also be inviting some new teams with us to chat through some of the recent Injective developments. I know we had a recent Twitter Spaces with Neil and the Eclipse team to discuss Cascade, which is the first SVM rollup within the Cosmos ecosystem. But that was mostly on a high level because we wanted to host another panel, this panel, during the hackathon to shed more light and also invite the teams from Celestia and Solana to come chat with us and provide some context from their perspectives on why Cascade is impactful. Before we dive into the questions, I'd love for all the panelists to introduce themselves to everyone who is listening. So if you can give a brief background on yourself and the project that you are working on. I think we might still be waiting on Matt. Let me do a quick scan. Matt, if you are in the audience, please request speaking rights. Maybe we'll start with Nick, and then we will go to Neil and then Eric to close us out.
Hey, everybody. Thanks for having me. I'm Nick. I'm COO of Celestia Labs, and we're building Celestia, which is the first modular blockchain network. And Celestia is the first blockchain that is just focused purely on something called data availability, which is sort of like the core fundamental bottleneck to scaling blockchains. And Celestia has some unique properties, which is that it can scale its block space with the number of nodes in the network. So for the first time, sort of in the history of blockchains, we can have a blockchain that doesn't have sort of this finite capacity that can actually grow as there's more people using the network. And second of all, Celestia is verifiable by anyone through this novel technology called data availability sampling. People can verify the Celestia blockchain with very light hardware, such as just a smartphone. So those are the key properties, and Celestia is purpose-built for rollups. So that's why I'm really excited to be here to talk about Cascade and all the things that Injective and Eclipse are building together. So thanks for having me.
Yeah, that's awesome. I also see that Matt just joined. Matt, do you want to give a quick intro to yourself, a brief background, and then the project that you are working on?
Yeah, hey, I'm Matt Sorg. I do a lot of tech things at Solana Foundation, which you can think of as basically the ecosystem side of the Solana ecosystem. You have labs that and FireDancer that make the two core protocols, and Foundation does a lot of help with the ecosystem. So I don't know, the operators, so like validators, and then also any projects that build on top. So that's why I talked to Neil a bunch about the SVM ecosystem and how do we kind of facilitate and work together. Help scale. I guess a little bit about me. I have a technical background, two-time founder, one of which is in the blockchain space. The other one is direct-to-consumer hearing aids, and nothing to do with blockchain. But really like startups, really like exploring new ideas and trying to add value to wherever I can. And excited to chat with everybody today.
Yeah, that's great. And then Neil, do you want to reintroduce yourself to the audience? And then Eric, you can close us out.
Yeah, so I'm Neil, CEO and founder of Eclipse. And what Eclipse does is it lets you build your own rollup, where a rollup is a type of modular blockchain that takes blocks of transactions and stores those on some other layer one blockchain, which is why I'm glad that Nick went before me, because I can use that as a building block. So we use some other blockchain for data availability, but a rollup does execution for itself. And what that means is that you can change that execution layer in ways that maybe don't match the layer one blockchain. So in this case, we've created a rollup where it uses the SVM or the C-level virtual machine, but it uses some other blockchain under the hood. So this is specialized for the Injective ecosystem, where the plan is charge gas and Injective's native token and build in additional features that are unique to this blockchain.
Yeah, we'll definitely dive into that a little bit more. But Eric, do you want to give a quick intro to yourself, just because all the other panelists also have,
Sure, of
and just
course.
reintroduce your role?
Yeah. So Injective is a blockchain built for finance. It's an open, interoperable layer one blockchain powering the next generation of DeFi and financial applications, including, for example, decentralized spot and derivatives exchanges, prediction markets, lending protocols, and much, much more. It has a set of very powerful core financial infrastructure primitives that applications can leverage optionally, including a fully decentralized MEV-resistant on-chain order book, Oracle modules, and different types of derivative primitive. In addition, all forms of financial markets are fully on-chain, and the decentralized cross-chain bridging infrastructure is compatible with Ethereum, IBC-enabled blockchains, and non-EVM chains such as Solana. So yeah, really excited to talk more about interoperability and rollups.
Yeah, I think that that's great. And it just kind of gives a perfect segue into the first question for today's panel. So, again, we're all here today to discuss the recent launch of Cascade, which is the first SVM rollup within the Cosmos ecosystem. And specifically, as was mentioned, we'll dive into Solana, data availability layers such as Celestia, and a lot more. But maybe Eric and Neil, if you want to chime in and let us know and give a brief description of what Cascade is, and what it actually brings to Injective and then the larger Cosmos IBC ecosystem.
Yeah, I can take that. So Cascade, wait, so what Cascade is doing is a couple of things. One is that it's the first live SVM testnet chain in the Cosmos ecosystem. So you can actually go ahead and start deploying Solana programs to this chain. Of course, the wallets are a little bit clunky right now, but that's something that we're close to solving. But that is what looks like the initial contribution to the Cosmos ecosystem. The second thing is that these chains are IBC connected, meaning that you could pass IBC messages between Injective and the C-level virtual machine on Cascade. And that's typically a difficult thing to achieve. And historically, there's been talk about having the Solana layer 1 incorporate IBC, but it's a little bit difficult when you're using Solana consensus. But in this case, it basically requires a light client. But in this case, because we're not relying on Solana consensus, we're able to do it more effectively. So that's two contributions that Cascade is doing, and I'll let Eric speak more in terms of the significance to the Injective ecosystem.
Yeah, I think one of the very interesting aspects is that using the SVM as kind of like this smart contract layer allows for a lot of different takes on kind of program concepts and also primitives to be built. And then on top of that, having it going back and compose with the greater Cosmos ecosystem and composing with the Injective ecosystem applications are exciting to say the least. And on top of that, one of the most interesting aspects of Cascade is that it's secure and partially by the Injective validator set upon mainnet. And this means that the security of the Cascade rollup will be shared between the Injective ecosystem and also the Eclipse team. And on top of that, I think one of the really exciting parts is that for the first time, the entire Solana ecosystem, which can only exclusively deploy and work with the C-level virtual machine environment with the full feature and composability setup, are now kind of possible on top of Injective, are kind of possible to compose with the greater Cosmos ecosystem and really expand the reach of these applications both horizontally and vertically.
Yeah, I think that makes a lot of sense. And I know that we are kind of talking about SVM, but maybe some listeners here would love for us to distill the technical terms. So, Matt, maybe if you can give us a little bit of a background on what SVM is, why it's special. I feel like a lot of people might have heard of EVM before, but maybe it's not as familiar with SVM.
Yeah, I guess in plain English, the SVM is kind of where the code is run, or kind of how the code is run. There's different steps in the process. There's the consensus algorithm. There's other bridges. There's a bunch of things that kind of go on, and the communication protocols and all that stuff that happen with a a blockchain, but really this is just like talking about how the code is run and compiled, and so if I am an app builder and I want to make some custom logic and have it be run on the blockchain, coding it in Rust, Solana. Well, actually, SVM accepts multiple languages now. You could do C++. You could also use a couple languages on top of what's called Anchor, which is a basically a framework on top of the SVM, and so you can do that in Python, soon TypeScript, and a couple others. But then, yeah, the SVM is just where it's run. It's got a lot of benefits over EVM. It's really basically purpose built for a blockchain. It does parallel computation. It can help really route the incoming transactions very efficiently. It also really allows programs to be cloned, and so basically you can kind of just copy and paste the execution models very efficiently across, which is I think is really exciting to see as the proliferation of SVM happens. You can basically take a protocol that lives on any one of the SVM chains and just kind of copy it over to that functionality over to your chain, which is very different than the EVM world. So this composability and other things is pretty exciting, and kind of like why we're so excited by this effort.
Yeah, and as a follow-up, from your perspective, and this is honestly a question for all the panelists, but why we're talking and saying that Cascade is important, but what does an SVM layer within Injective and more broadly the Cosmos IBC ecosystem mean for the larger Solana community? And then, for Eric and for Neil, what does it also mean for the Cosmos community?
On the Solana community, I feel that this essentially cements the importance of this virtual machine in crypto in general. In the same way that so many folks just forked the EVM, like Polygon, Binance Smart Chain, that did great things for those ecosystems, but it also fed network effects back into the EVM. And it meant that people consider the EVM when they first dive into crypto. And similarly, I think if there's a lot of applications that can pretty much uniquely be built only on the SVM. Like central limit order books are fairly difficult to build without that. And of course, Injective, and if you can modify a layer one blockchain, so it's able to support it. But the SVM has native parallelism, so it's pretty trivial to just deploy a clob or something to that. So I think that now we can start seeing a lot of those applications start popping up in other ecosystems, which historically they haven't really had a way to do that.
Yeah. And Nick or Eric, any other thoughts that you want to provide?
Yeah, I think on top of that, it is kind of like this child that's coming from the collaboration of multiple ecosystems. Eclipse, Injective, but more importantly, a lot of the existing brain share from Solana and Celestia. And I think this is one of the marvels of open source and collaboration within this space. And this also means that developers can for one of the very first time to deploy their application beyond on the Solana chain, and really treat Cascade as both a scaling solution potentially for the Solana community, but also a composability and kind of like a interoperability kind of platform for all of these ecosystems to connect.
So what I think is really cool about Cascade as an idea is that it really represents the promise of a modular paradigm for building blockchains, in that you can decouple execution from sort of the underlying blockchain and sort of set it free and use it in new contexts. And so in this case, we're taking the Solana virtual machine, which is the second most widely adopted blockchain VM outside of the EVM, and kind of setting it free for the first time and opening it up, to be run on new chains with new applications, and giving developers the ability to deploy, a sort of dedicated SVM instance, which might be really useful and enable them to build things that maybe wouldn't make sense just deploying naturally on the actual original Solana layer one. And that's kind of unique to a modular blockchain paradigm, because you need to sort of have this ability to split apart consensus and data availability and execution. And I think as we go forward in time, we'll see more and more of this. And I think ultimately it'd be very beneficial to both the Solana community as well as the Cosmos and Celestia communities, because as we say, it's about modularism, not maximalism. Like, we should kind of free up all the different layers and allow them to be sort of composed and used to the best, I guess, the most like powerful combination. And I think that's something that's really exciting about Cascade.
Yeah, and Nick, you had also mentioned really briefly in your intro, that Celestia is the first modular blockchain network. For those who might not be as clear on, I guess, what that means, can you give a brief overview? And then also, like, maybe condense down a little bit, like, what does it really mean when we talk about modularity versus like a monolithic blockchain?
Absolutely. So when I say that Celestia is the first modular blockchain network, what I mean is that it's the first layer one chain that is built for a modular world. So every layer one chain, in some sense, can provide consensus and data availability, but most of them have, in fact, all of them, I guess, have been built with a monolithic paradigm, meaning that they do not just consensus and data availability, but also execution. And they're all kind of wrapped together in one single protocol, and that just inherently has limitations. The first limitation is block space. So monolithic layer one has a finite capacity of block space. And so eventually, as more and more applications are deployed on it, it kind of fills up, and you run into congestion and fees increase for users. And the second kind of limitation that monolithic blockchains have is that you're locked within one single execution environment. So that's kind of like, imagine if you buy a new computer, it's usually already has comes with an operating system like Windows or Mac, for example, and that limits the kinds of applications that you can run on that computer. And so blockchains are very similar in a monolithic paradigm, where they come preloaded with a certain VM. And in a modular paradigm, you break free from those limitations because you actually completely separate execution from the underlying L1, which just does only consensus and data availability. So Celestia actually has no smart contract functionality. It's a very simple and dumb blockchain, but that enables it to be extremely scalable. And so the block space, as I said in the beginning, can increase with the number of nodes in the network. And so you don't run into congestion. And second of all, you can run any arbitrary execution environment on Celestia. So it could be EVM, it could be SVM, you can run Cosmos SDK based blockchains, and even make custom VMs that don't yet exist. So that is sort of modular blockchains in a nutshell. And the execution layer that would run on top of Celestia are rollups, essentially. So that's where things like Cascade come in, or teams like Eclipse, who build sort of that layer and make it very easy for people to deploy execution layer chains.
Yeah, I think that that's great. And it gives a perfect segue to talk a little bit more about scalability in general. So I know all the projects here today on the panel are working to create infra that is more scalable than the typical norms within the industry. So this is honestly a question for all the panelists. What challenges or limitations do you think still remain with respect to scalability?
Yeah, I can kind of like start off and chime in on that. I think one of the biggest bottleneck when it comes to scalability within a monolithic environment is first of all like two fundamental problems. Number one is like the shared mutable ledger problem, and then the second one is really kind of like the reliance on sequentiality and also atomicity. And this means that basically everyone is trying to, write and execute within the same environment, and they're all interlinked together in one way or another. And while there are a lot of parallelization solutions, and Solana team has done a wonderful job of expanding upon that feature, but one of the still like remaining bottleneck is that these type of kind of parallelization still relies on kind of like an idiosyncratic kind of like a execution chain, which within like an increasingly composable and increasingly atomic kind of ecosystem of decentralized applications will still create like a issue around scalability. And also like everyone trying to write the same type of shared global state will also kind of decouple or like kind of weaken the advantages of parallelization. And this means that over time you're just going to see kind of like a bottleneck if all the dApps and all the kind of like environments are all relying on the same kind of like a canonical sequential like execution or transaction sequence. And I think L2 certainly resolves a lot of that. Rollup modular blockchain certainly will be kind of like a paradigm shift when it comes to truly scaling the application level. And for Injective's case, one of the most heavily used or one of the most active module is the exchange module. And utilizing the frequent batch auction actually resolves a lot of the inherent scalability issues that are persistent within any type of blockchain. And by employing frequent batch auction in a time agnostic and sequence agnostic way, basically there are quite a few elements, if not all, that can be made batched and parallelizable. And this basically implies that Injective can be hyper scalable and evolve along with kind of like the growing research and development and the technology stack on the exchange module aspect. But that being said, there's still a lot of work to be done on the smart contract layer. There's a lot of work to be done on different aspects, and a lot of innovations with the modular stack of blockchain will certainly improve and help. And on top of that, basically, I would say that by sticking to kind of like a way of thinking and design within EVM, kind of beholden decentralized application developers into a certain mindset of composability and the requirement or the necessity for atomicity, and the faster the space kind of like decouples from that, and building a lot of infrastructures to alleviate the kind of like the cons of losing out atomicity, the better these application will be able to scale to service the billions of users that can onboard.
Yeah, that's great. Thank you for that overview. Wondering if any of the other panelists had any thoughts about what Eric just shared, or also just thoughts again on the question of what challenges or limitations do you think remain with respect to scalability?
Yeah, on that like global state point, I guess like to some degree, even in like a centralized system, it's not really like it's hard to get around that. If let's say there's a ton of writes and reads to the exact same piece of state, then it's hard to scale that in general. But I think unique to crypto is like the concerns about like, because we want to make it decentralized and we want anyone to participate, that means that we don't want to rely on like, let's say, special hardware for a particular application, or we don't want to build in like special types of operations in general into some kind of shared chain that everyone's supposed to be using, because a special hardware means that fewer people are able to participate. But that's what I really like about rollups, which is now we can have chains that their execution layer does rely on that special hardware, and even if the number of nodes that run that rollup are fewer, it's still like you get to share the security budget of some other blockchain. Because typically, if you try to run your own layer one blockchain for all these bespoke different execution layers, you'd have serious security fragmentation. So that's one thing that I think that like these like projects like Celestia are really solving. And then on the side of what's remaining, I think just like the process of in the direction of rollups for scalability, just the continued process of like further decentralizing it is something that's still a work in progress. And I think that there's a pretty credible path to doing so.
Yes, and then once scale is actually achieved, there often remains issues with interoperability. I know big value add that Cascade is aiming to bring is to provide an SVM layer with the IBC ecosystem, which can ideally provide seamless interoperability. So, how are your projects tackling interop? What building blocks do you think will help us reach higher levels? Do we think that also the way that interoperability works today is like the final, I guess, iteration, right, of what it's going to look like in the future? And that's an open question for all the panelists.
I'll jump in here for a bit. So Celestia is unique in that we see that kind of like the current sort of paradigm of interoperability is actually kind of inherits trust assumptions. So IBC or pretty much any bridge live today, when you're using it, you're assuming either that a independent committee is honest, or you're assuming that the counterparty chain will be honest. And I think that's fine in certain cases, but if we want blockchains to scale to having millions of chains in the future, basically scaling to the size and the diversity of the internet itself, which I think is where we want to go, we need better models that have sort of weaker trust assumptions. And a really cool thing about the modular paradigm is that you can build these things called trust minimized bridges, which are essentially bridges that verify the other chain. So you no longer have to actually trust that the other chain is honest. You can actually verify that the state that they're like sending you is accurate and valid. So we think that this is sort of the future of interoperability, and it's uniquely enabled by separate chains or rollups sharing a common data availability layer like Celestia. So the cool thing about Celestia is it has this sort of like property where if two rollups are posting their data and their blocks to Celestia, they can have this trust minimized bridging functionality. Now, the thing is that there's still a lot of things to be built to make that possible. Luckily, the data availability layer will soon be there once Celestia launches, but we need to extend and upgrade interoperability protocols like IBC to support this new use of them. And it's non-trivial because you have to, there's just a lot of sort of like nuances to this model. And also we need better sort of proof systems for these chains. So things like, fraud proofs and ZK proofs to basically prove the validity of the state underneath it. And luckily, though, there's a lot of teams that are working on this. And I think that it will get built and it will happen. And once we get there, you'll enter in this new era of shared security and interoperability.
Yeah, and then I think I have a follow-up question for you, Nick, and then Neil. Again, Cascade plans to integrate Celestia for data availability. We'd love to hear from you both how Celestia will fit into the data availability layer, and how Cascade can achieve further scale using Celestia.
Oh, mind if I jump in here real quick?
Yeah, of course.
Yeah, so I think one of the most amazing thing about Cascade, and completely made possible thanks to Celestia, and obviously a lot of the existing work done by the Solana team, is that it's one of the very few roll-up or scalability solutions out there that can break away from the single operator model. And this means that for a lot of the L2 solutions today, such as basically, Optimism, Arbitrum, or, ZK Rollup, etc., all practically requires a single operator to maintain, like this source of truth. And because of, like the data burden and a lot of different types of networking issues, it's a natural convergence towards a single, operator that's completely centralized to be able to maintain, kind of liveness of this rollup solution. But this is completely not the case to Cascade. It's actually, decentralized. Different components can be split up by, a set of validators and secured by, different types of parties. And more importantly, over time, I can expand into more and more operators, and even evolve into its own, kind of like a consensus secure chain, whether that be proof of stake, etc. And I think that is, one of the most exciting thing about, all of these kind of like modular blockchains and all of these scalability and rollup layers for Injective, for Eclipse, etc. That's completely different from, a lot of the kind of like the dominant L2 solutions.
Yeah, and I think that Eric, you were also mentioning a little bit about like data burden. Nick, if you want to provide a little bit of context or background, because obviously Celestia focuses on data availability, but not specifically data storage. So can you provide some context for the listeners on what the difference between that is, and yeah, what Celestia is really seeking out to do?
Thanks. So I'm glad you asked this question because data availability, I think it's a very confusing term, mostly because of the name, I guess. It's also a very nuanced concept. So what data availability is very different to data storage, even though the names sound similar. So data availability is solving the problem that in order to have these sort of shared state machines, which are blockchains, we need to have sort of common data that is publicly available for anyone to download and inspect. And that is sort of like just a fundamental property that these systems need in order to be secure and transparent. And so what data availability is specifically like, and so if you want to build a blockchain, typically the way that like a monolithic blockchain solves for data availability is that they require every node in the network to just download all of the block data. So every time a block is published, every full node will download that entire block and re-execute every transaction. And so in a sense, they're ensuring that the data is available by directly downloading it. So they're proving to themselves that the data is there by actually, going and pulling it from the internet onto their machine. But that doesn't scale because as the number of transactions increases and as the blocks get bigger and bigger, you will need to start downloading more and more data. So now if let's say that block size increased by 1000x, you will need 1,000 times more bandwidth to download that block data and verify that it is indeed available. And so this is where a blockchain like Celestia comes in and a technology called data availability sampling, which is essentially a technique where you can verify that the data behind a block is available. Like you could download it if you wanted to. It's been published to the internet, but you don't have to download the entire block yourself. Instead, you select random samples of the block and download that. And the more samples you download, the likelihood that the entire block is available increases. It's kind of like flipping a coin. Like the more times that you flip the coin and it lands heads, the more likely it is that the block is available. And so what this means is that the block size can grow by 1000x, but the amount of data that you have to download grows only a very small amount. So people can still verify the blockchain without verify that the data is available without actually having to have a very high resource node. And verifiability is really important because that's what blockchains are all about. They're about minimizing trust assumptions. And the way that you minimize trust assumptions is by not trusting someone that something is valid, but by checking it yourself. And so that's why it's really powerful. And just a side note is that data availability is sort of the fuel that all rollups run on. So rollups need to post their transaction data somewhere that people can verify that data is available, and that's necessary because people, for an optimistic rollup, they need to be able to generate a fraud proof. If the data is not available, the other nodes in the optimistic rollup can't generate a fraud proof. And in a ZK rollup, if the data is not available, no one can actually reconstruct the state of the chain. And so you have this danger that the chain could be halted and no one would be able to sort of continue producing blocks. So that is what data availability is in a nutshell. Data storage, by the way, is ensuring that the data is going to be around for a certain period of time. And it's very different. It doesn't actually help you verify that the data is actually there or has been published. It's about data persistence, if you will, or retrievability, which is a very different problem.
Yeah, that's great. Thank you so much for that overview. And also just going to do a little plug here because this is part of our hackathon. For more details on like the how-tos, how this will all be working together, we are going to be hosting an Eclipse workshop at 11 a.m. Pacific Standard Time. So that's in about like 4 hours from now. And so that'll happen on our Discord. But yeah, I wanted to switch gears a little bit because, we are talking a lot about on a technical level, how Eclipse, Celestia, Cascade all kind of like work together. But wanted to maybe hear a little bit more on how this works from like a user perspective once an app has actually a Solana app has actually launched and utilized Cascade to launch on Injective. So maybe this is a question for Matt. Is the experience going to be exactly the same from a user perspective, right? Whether or not you're part of the Injective or Cosmos IBC ecosystem or the Solana ecosystem, like how will that work? And how can the DApp tap into IBC and native Injective modules?
I can speak to kind of some of the core differences. I wouldn't be able to speak exactly to the Injective stuff, but I mean, I think the main thing when you're across like an ecosystem is really about the tools and like quite literally like the ecosystem of both the operators, like the validators who are running it, and then all the infrastructure built on top. And infrastructure kind of defined as like the wallets, the RPCs, anybody reading and writing and collaborative, like basically whatever business operations that are happening. So yeah, I think that's like kind of so if you're going from Solana mainnet, which kind of has 2,000 validators at any given time and a bunch of wallets and other operators, so it's like this great ecosystem. And then you could both, when you make another SVM, you do have to kind of figure out those, and that's kind of like actually what Celestia and these other apps do, is that they kind of provide some of that stuff out of the box, and then they give you some configuration options for other parts of it. We make it a lot easier to do that, because there are a lot of challenges if you don't have some system for that. But then they also provide, like I was saying, like the data availability and kind of that level of the infrastructure as well. So from the dApps perspective, it's really just about like, do you want that configuration option and knowing that you'll have to do a little bit of extra work and a little extra thought because some of the stuff isn't made for you, like the RPCs and other things. So it's a kind of configuration versus being part of a larger ecosystem that you can kind of collaborate with. So that's like kind of the choice of the builder, I think. I don't know if anybody else has any distinct thoughts there, though.
Yeah, I think another, just to name, one example off the top of my head. First of all, utilizing IBC, it's basically like a generic message passing layer. So this means that any type of forwarding instructions or any type of very interesting kind of like composability ideas are all completely possible on top of IBC. It's really about how different types of dApps handle these type of forwarded requests or forwarded instructions. And on top of that, the native injective module with the help of a few potential smart contracts or different types of native work can make basically the SVM Cascade layer completely composable and interactive with or like interoperable with the injective exchange module, or even grab price fees from the Oracle layer, or creating on-chain strategies that for the kind of like final instruction onto injective in a much more computationally efficient way, and also being able to create markets, being able to have a concentrated liquid venue on top of the injective exchange module, but at the same time having these type of atomicity and composability in like a cross-chain equivalent of atomicity by basically enabling non-interactive kind of like instructions or transactions. Like these are all possible, and that's something like I'm really excited to see more and more. Where there could be on-chain strategies that are running off of the Cascade that are submitting or executing on top of the injective exchange module, or there could be lending protocols or margining mechanisms that does most of the bulk of the parallelizable computation on the Cascade layer, and extending the loan or credit on top of injective, or even having like a Solana native application, being able to like compose and extract liquidity from injective to create a much stronger kind of like flow or execution.
No, I think that's great. And Neil, I don't know if you want to hop in here and also kind of give your 2 cents on maybe the long-term vision for Cascade, and what more can we expect to see in the world of rollups as it relates to Eclipse or alternate virtual machines.
Yeah, I think that Eric did a great job of talking about the different directions that this chain's use case can move in. And I think I'd add on a couple, like, for example, we can add in a mempool into this pool, into this chain, which historically the Solana L1 doesn't have a mempool to optimize it. But I can imagine like a mempool that redistributes the MEV, for example, or similar to what the Injective L1 does. We could build in a frequent batch auction to enable applications that couldn't exist in Solana or couldn't exist in Injective. I can see this being used for like NFT mints, like mass NFT mints, and we have some projects with some fairly big NFT like PFP projects that we haven't announced yet. But I could see that kind of functionality being incorporated into this chain, because Cosmos doesn't have like a great chain for NFTs, in my opinion, at this point. So I think that this could serve as that hub potentially. So those are like a couple of ideas for this chain in particular. As far as Eclipse in the future, I think that I could see a lot of ecosystems spinning up SVM chains or SVM rollups for their ecosystem via this mechanism, and to kind of mimic what Injective is doing. And we've had a lot of ecosystems reach out to us, a lot of other Cosmos chains in particular, but also like non-Cosmos. So I think that we're going to see a lot of like mass SVM adoption, and I think that we're going to see a lot of folks mixing and matching the features that they're seeing that are interesting from other ecosystems that maybe they can't build into their layer 1 just because it would like damage like the way that applications were historically constructed on that chain, but they would want to have some kind of almost canary network that they can experiment with. So that's what I'm seeing as the future, where people spin up like quite a few more of these chains that are more specific to their ecosystems.
I think like like inherently SVM also has a lot of advantage. Like basically AI is, I guess, like the hot thing these days. And one of the things that's really interesting with the SVM is that it's highly parallelizable, and it's inherently parallelizable. And this also means that it's very friendly for scalar multiplication, and it's very friendly for any type of like data relatively light, but computationally intensive tasks that are at the same time parallelizable. These are all possible, and by having this type of like new environment, it creates a much more friendly kind of or completely new possibilities for different types of verticals of decentralized applications.
And for those who wanted to get started with Cascade today, Neil, have we shared just yet on how developers would be able to get access to the testnet?
Yes, if you maybe we can post a link after or something, but it's docs.cascadehq.xyz, and you should go to those docs, and maybe we'll also like link the announcement tweet where those docs were linked, and people should start trying it out, giving us feedback on the chain, things that they'd like to see or things that are going really well, and we'll be sure to incorporate that as we continue adding improvements to this chain.
Yep, we'll definitely be sure to post those links. And again, for the Injective Hackathon, we have the workshop in a couple of hours on our Discord on how to access and how to get access and also how to utilize. And then I'm taking this one from Mirza as we kind of end to do a little bit of a hot take. What is one hot take that you all have with regards to crypto, scalability, modularity, AI, any other relevant topic that most would not agree with? If you guys want to give a hot take before we close.
Yeah, I'll give one. So this is motivated by, I don't know, earlier Nick was talking about like bridging and trust minimized bridging, and I think that that's like it's a useful term, but I also feel that trust minimized bridges historically have been like I think that the emphasis has been a little bit overdone, and I don't know if there's actually that much utility from a user's perspective of a trust minimized bridge versus some other kind of bridging. So that would be my hot take, which is that it's just a little bit overrated at this point.
Bold hot take. Anyone else have a hot take to share before we close it off?
I think the recent stuff around LLMs and all the hype around ChatGPT and stuff like that, for it to be production ready and kind of like public rollout ready, or to see like a substantial form of commercial adoption, we're still 10 to 20 years out, and basically right now like there's certainly a lot of like early type of applications and adoptions around it that are certainly getting a lot of hype and certainly very, very useful, but at the same time the hidden force of unit economics is going to kind of push out a lot of these applications in the long run.
Oh, 10 to 20 years out. Oh, Nick?
Yeah, I don't have a specific hot take, but I will agree with Neil that in the short term, the sort of like committee-based bridging and sort of like the current sort of standard and paradigm of bridging that is trust-based is actually going to be great and has a lot of advantages over trust minimized bridging in terms of latency, and the security is good enough. But I think where trust minimized bridging will matter is further in the future when the ecosystem grows by, let's say, 100x or 1000x, and we need like a lot more capital efficiency in bridging, and there'll be just so much value and I guess messages to bridge that like the current models like of trust-based bridging will break down. So in the near term, it's not that important, but I do think it's really important that we get there eventually, and that we have technology that can do that. Otherwise, I think it would be a ticking time bomb for blockchain ecosystem broadly.
All right, and then I'll throw it over to Matt. And this is just open also if you wanted to share any final thoughts or anything that's upcoming that you guys are working on, just to kind of close this out.
Well, I've been a little bit distracted in this call because Helium launches on Solana today. Yay! So that's cool. If people don't know what that means, Helium was on its own L1. It is a decentralized, like basically internet, and it is both utilizing a technology that we rolled out recently called compressed NFT, or like, I don't know what the official branded name is. Basically, it's it's a kind of a it's a lower cost NFT system. So they're going to mint NFTs to represent all the hotspots. So it's a decentralized, internet network. So a bunch of people just independently, permissionlessly run their own hotspots, and they're going to have their kind of operation be represented as an NFT, so they can trade it and all the nice properties of, this is like pure utility NFT. So they can kind of get the rewards from hosting their internet through this NFT representation. So it's really cool to actually like see these technologies kind of be on a very, very functional application. And they weren't able to do that on their own L1 because they didn't have a bunch of smart contracts and stuff on that. So that's really exciting. I think that I'm kind of overviewing right now as we speak, making sure the RPCs are, everything's set up correctly, because it is a new, we're not really worried about it from the volume perspective, but like they are using a bunch of new technologies, which is kind of cool to kick off. I think on the spicy take thing though, it kind of like related to this, I think that blockchain is ready, I guess, to have some really awesome applications. And I think I'm obviously working on the infra side, so it's it's not like I'm against further developing infra, but I would just like kind of challenge everybody in this call, especially that are builders, is really thinking about that killer application that makes use of blockchain. Like what are the ecosystem effects that you can kind of facilitate with other apps that you're building alongside, and what's really going to add value to a user, and like really understand that user persona. Because I think, again, I'm working in infra, so I think it is a very valuable thing to think about, like what the future is going to hold for blockchain. But I do think that we really need to start seeing some apps get product market fit as well. And that would, I think, just help the whole ecosystem out.
Yeah, that's
congrats.
awesome. Congrats. Yeah, congrats on Helium. We end with you heard it first live. I also like the rebranding of a hot take into a spicy take. So if you don't mind, I'm going to use that moving forward. But thank you so much to all the panelists for joining today's conversation, and for everybody who's here listening in. Hope you found that just as enlightening as I did. And again, we are going to be hosting an Eclipse workshop in the next 3 hours for the Injective Hackathon. So builders, please come and join, learn how to utilize Cascade, find that new user perspective app, because as Matt says, blockchain is ready. And thank you so much for joining, and we'll post this panel on our YouTube shortly so you can listen in again. But thank you so much, everyone. Have a good one.